is a question from paper 2, so it's an AS level question, although it could quite as easily come up on paper 3. And what I was going to do is going to go through this as a pseudocode question, and then for those of you in year 13 or for those of you in year 12 who want to get yourself prepped and ready, I'm then going to try and convert it into Python. So let's have a quick look at the question. So the question says that a program displays a progress bar to inform the user of the progress of tasks that take a significant time to complete, such as those involving file transfer operations. And we can see that here. Now it says task progress is divided into 11 steps, and each step represents the amount of progress as a percentage. An image is associated with each step, and each image is stored in a different file. Different progress bar images may be selected. For a given image, files all have the same file name roots with a different suffix. So we can see for step 1, which is any percentage progress less than 10, then the roots, of course, you can see here's bar graph A, and then it is hyphen or dash 1.bmp. That's how old the people are from Cambridge setting computer science questions. I haven't seen a .bmp file in many years. So we can see step 2 is when the percentage progress is greater than or equal to 10 and less than 20. And of course, it's step 2. The root is bar graph A, and so it will be dash 2.bmp, and so on, and then until we get to 100, which is the 11th step. So it says a procedure, so it's important, we know it's a procedure, well, there's no return, and it's called progress, and it's going to be called with 2 parameters, an integer parameter representing the percentage progress, so we can call that, we'll come to think about what that is and thing, and it's 0 to 100 inclusive, and a string representing the image file name roots, and then it will generate the full file name image and call a procedure called display using the full image file name as the parameter. And that is what we need to do, is we need to write this procedure called progress. So it starts out pretty straightforward. Procedure, progress, and it takes, let's call it the actual percent, and we know that that is an integer, and what is it? It's called the roots, okay, which is a string. So let's think about what we need to do here for getting marks. Well, for getting marks, let's don't forget our procedure. We need to do that. And at some point in time, we're going to have to convert percent to a step value. Then we are going to need to convert step from an integer to a string so that we can concatenate it. Then we need to concatenate the file name, and then we need to, well, we can just simply write it. We can call, it's called display, and we can say, we might as well call it file name, makes a sensible name. So how do we convert a percentage to a step value? Well, let's just not worry about that. Let's just, for the moment, just say that the step is 1, just so we can think about, well, how do I convert that from an integer to a string? Well, I can say that the step is, and we know we have none to str, and we can say step. So that fills that one. Now how do we concatenate? Well, so we can say that the file name is, and we concatenate, so we know it is the root. Then we have a hyphen, and then we have the extra step, whoops, and then what do we have next? We then have the dot bmp. Now of course you can use plus, ampersand. You want to be completely pseudocode, and then of course we've declared and displayed the file name. So we've got, if the root is barcode A, that will be barcode, oh sorry, bar graph A dash, and then the str and step. And I happen to know, although I haven't actually looked at the code from the mark scheme, I do happen to know that you will get 1 mark for this, and you'll get 1 mark for this, and you'll get 1 mark for this. So that's 3 marks. You won't get, strangely enough, any marks for this, because the mark scheme says after a reasonable attempt, and of course we haven't made any reasonable attempt, but it's worth 6 marks, and we've got ourselves 50% without really having to do any thought process. So that's not too bad. For some of you, that'll be a very good mark, 50% on this particular type of question. So how can we do this? Well, what do we know? We can write, and this is not the right way to do it, but let's just think how we can do it. We can say, first of all, I'll just declare step as an integer, and I can say if the percent is less than 10, then I want to say that step is 1. And then I can say if percent is greater than or equal to 10 and percent is less than 20, then step is 2. And I could keep doing that. I could, of course, I would need an end if here, and an end if here, and an end if here. And that's going to take me quite a long time to write out, because I'm going to have to do 11 of those in the exam. Of course, if we were to risk using elifs, then we could say if it's greater less than 10, then do that. Else, if it's less, else, if percent is less than 20, else, if the percent is less than 30. It saves a little bit of time, but it's still not ideal. And of course, else if technically isn't in the pseudocode guide. We could, however, be a little more clever, and we could say case of percents, and we could write less than 10, and remember it is just like else if. Now it is exclusive, so if it meets one, it meets the other, and we could do something like this, and kindly, if it is 100, then step is 11. Now, of course, that's still going to take some time, but it's a little bit nicer than having to write if, else if, etc. Now, and of course, we should then of course write end case. That's still a lot of work to do. If we use our brain, we can actually be a little bit more clever, because realistically we're asking if it's less than or 0 to 9, step is 1. If it's 10 to 20, step is 2. And we can use that wonderful mathematical operator called div. What does div do? It will give you the integer division. So if I take percent and I div that by 10, what will I get? Well, if I've got 0 divided by 10 is 0, remainder 10. Well, we're looking at the 0 part. 1 divided by 10 is 0, remainder 1. It's the 0 part. So all the way up to 9. 9 will give me 0, remainder 1. So that will give me 0 in the div part. Once I get to 10, 10 divided by 10 is 1, remainder 0. So I now have 1. And then 11 still keep me 1. And then 20 will give me 2. So we get 0, 1, 2. So if we said that step is percent div 10, then that would give us, for 100, that would give us a step of 10. And for 0, it would give us a step of 0. And we actually want 1 to 11. So we can simply just add 1 to it. And of course, we need to be able to think about things like that, because you can see how little time that took. Now remember, it's important to think, this is a 6-mark question. You've got about 8 minutes or so. Well, this first part here and this really was take a minute, 2 minutes maybe, 2 minutes to do that. It gives you 4 minutes of thinking time to write that one line of code. So it's important, don't rush into it. Think about it, because now we have a 6-mark answer. We get 1 for the procedure definition with an end procedure, 1 for calculating the step, 2, 3, 4 and 5, and then also for making sure that we have a 1 here. So that is the answer to the question. Now, if you can't be bothered about Python, you're in year 12, then you can stop watching now. Alternatively, you can carry on, and I'm going to see if I can convert this to Python. That's not the best of starts, is it? Okay, so let's just quickly make some changes to this. Of course, we can't declare step, and this is a def, and the def is called progress, and we don't need to have that. So we have this, and we can say that step this time is equal to percent. Now the div operator is simply //10, so there's not a lot of work there. Of course, we do need to indent all of that. Of course, I'm just going to put an end-def here. So there was really not much change from pseudocode to Python here. Not much change, just change the comment to a hash instead of a //. And of course, we can now use the str. That was pretty straightforward. Instead of num to str, it's just str. Concatenate the file name. Well, had we kept it with commas in the first place, that would have, I mean, pluses in the first place instead of ampersand, then we wouldn't need to change anything in this line. And of course, we want to display file name, and of course we don't have a function called display file name. Hopefully that should work. Now, of course, for those of you in year 13, if you remember back to the software development lifecycle and testing, and we had various types of testing, and one of those was stub testing. For those of you in year 12, I'm not quite sure what that is. For example, display, this procedure may be being written by another team. You've been asked to write this progress function, but somebody else has done this. Now you can test this until they've given you the display procedure, or at least you can't test it properly. So what we can do is we can create what's known as a stub method. So I'm just going to call this display, and it's going to accept a file name, and all I'm going to do is print the file name, and now I have a stub test. It doesn't do what it's supposed to do, but means that now this will run. So let's see what happened. Make sure that I'm on current file, and if anything, we obviously need to call that. That would be a good start. So we're going to go progress, and let's start with 0. That should give me that should print 1 if everything goes to plan. And it says we're missing, oh, of course, because we want this, which is, we're calling that bar graph A. So we'll try that again. And we get bar graph A1. That's brilliant. Change that to 9. That should still give me 1. Brilliant. Let's change that to 10. That should now give me 2. Which it does. It's greater than or equal to 10. And then let's go to the extreme of that. So 19 should still give me 2. It does. 20. That should give me 3. If you look at that, greater than or equal to 20. So it's equal to 20. So it should give me 3. And just to check, we'll go to 29. That should give me 3. And then let's check. Now 99 should give me 10, which it does. And 100 should give me 11, which it does. So we've successfully converted from pseudocode. We can maybe take this back a notch. And if you ignore the declare here, this was pretty straightforward to convert to between the two. The difference between them is negligible at the whole point. If we understand one, we can go to the other, and vice versa. And so, of course, if I was writing this from scratch, if it was just for Python only, and the only thing that I have to keep as camel case is display, because that is down here, and progress, but nothing else requires that. So that is how I would write this program. 3 small steps. Hopefully that will help you to understand. This is a really simple 6-mark question which we could have answered. We're using lots of if and else if statements here, or with a case statements, or if we use our brain, we could do it in one simple line to get 1, 2, 3, 4, 5, 6, 7 lines of code for 6 marks in 8 minutes. It's not particularly difficult. Okay, hope that helps.